An insurance company purchases perpetuity due at annual effective 12.5%. The perpetuity provides annual payments according to the repeating 3-year pattern. So we see here that we can divide this perpetuity due into 3 streams. So due means that it starts right now. So if you look at this 100 and then you skip the next 2 and then you look, there's another 100, then you skip the next 2 and there's another 100. So the first stream would be starting at time 0 and it pays every 3 years, 100 here, 100 here, 100 here, and so on. And then the second stream starts at time 1. And again, we look at this one, the second payment, and then we skip the next 2, and then it's again an X, and then we skip the next 2, it's again an X. So the second stream is X, 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 and so on. And again, every 3 years. And then the last stream starts here at the third payment. So it's 100, you skip the next 2, then it's 100, you skip the next 2, then it's 100, and so on. So what's going on is that at times 0, 3, 6, and so on, we have payments of 100. And then stream 2 is payments of X, that those are at times 1, 4, 7, and so on. And then stream 3 is again payments of 100, and those happen at times 2, 5, 8, and so on. And since each of these streams pays every 3 years, we need the 3-year effective rate J. So we use our basic conversion equation, 1 plus I is equal to 1 plus IM over M power M, and M in this case is 1/3, since payment happens every 3 years. And so the annual effective is given to be 12.5%. So 1 plus 0.125 equals 1 plus J power 1/3. Remember, J is the IM by M. And so we get J to be 0.4283. So if we focus on the first stream, the present value of the first stream is found by the basic perpetuity due present value formula, 45.4. So it's the payment times 1 plus interest rate over interest rate. So payment is 100, 1 plus 0.42 divided by 0.42, and that's 336. Now again, if we treat the second stream as perpetuity due and apply equation 45.4, then the present value, remember for perpetuity due, the present value is at the time of the first payment. So for the second stream, since first payment is happening at time 1, so if we use the perpetuity due present value formula, it will give its value at time 1. So the value at time 1 for the second stream is X times 1 plus interest rate over interest rate. So when we substitute J, we get 3.36x. And now we need to bring it back to time 0. The first stream was already at time 0 because we didn't need any adjustment once we applied the formula. But since the second stream starts at time 1, so to bring it to time 0, you multiply it by 1 plus the interest rate power -1 to bring it from time 1 to time 0. And so it ends up being 2.9867x. And again, if we treat the third stream as a perpetuity due, then the perpetuity due formula will give its present value at the time of first payment, that is at time 2. So the payments are 100. So you will get 100 times 1 plus J over J. And that's again 336. But now we need to bring it back from time 2 to time 0. So we multiply this time 2 value by 1 plus annual rate power -2. And since we are bringing it back 2 years, and so that's 265.5. So the total present value is the sum of the 3 streams, so 336 plus 2.9867x plus 265.5, and we are given that the total present value is 9450. So from here, x is 2963, that's choice B.